Yo, hope you guys are doing well. It's still November 13th. I am on video number 4 for the day. I feel like I'm crushing life. It's 10:15 in the morning. We had a meeting until 8:30. I made video 9. It took me about 10, 12 minutes. I told you I spent 45 minutes getting ready. Now we get to start playing with the calculator. So I'm not sure how this is going to go on the video. So if this needs to be retaught in class, which I'm sure it will because you don't have these calculators at home, what I'll suggest right now is making sure that when I start using the calculator and holding it up and showing you, you actually write down steps. Step 1, I press. Step 2, I press. Fair enough? Fair enough. We are in, we are in lesson 14. Now we are modeling relationships with a line. So if you've noticed, I've kind of jumped the gun and I started making those lines of best fit on your graphs already. You should have seen in all of the videos with the scatter plots where I'm kind of already done the line, okay? Today, we are going to find how to find out the exact line of best fit, and we call it a linear regression. So looking at this, you should be able to say, hey, this appears to be positive. This is a positive, and it appears to be a linear regression. This line appears, or these data points, appear to be positive. Okay? That's not hard to see. Investigate this and say, okay, well, how do we know? Because as the shoe length gets bigger, the height should get bigger. Fair enough. So what do we truly want to do? Well, we want to be able to use these data tables, these coordinate grids, and we want to say, okay, what can we do with this? Well, let's find out. Is there a relationship? Yes. How would you describe the relationship? Linear. Do the men with longer shoe lengths tend to be taller? Yeah. Well, that's great. That's an easy one. Okay. But here's the same graph with two different models. Why is blue better than the black? Well, again, hopefully at this point, I've kind of talked about it and you can understand X is increasing, so is Y. So it's not going to be a negative correlation. It should be positive. Even though this goes through 2 points and this doesn't go through any, we're still pretty pleased with it being a positive correlation. That's something important to know. One of the men has a shoe length of 11 and 8 inches and a height of 71 inches. Circle the point in the scatter plot in exercise 3 that represents this man. So 11.8 and 71. So let's go back here. 11.8, right around here, and 71. Okay? Why do they have me do that? Don't know yet. Let's find out. But knowing how to be able to find those on the graph is important. That's how we're going to interpret this, because you need to. Suppose that you do not know this man's height, but you do know that the shoe length is 30 inches. If you use the model this, what would you predict his height to be? Okay, so I have y equals 25 and 3/10 plus 3 and 66 times 11 and 8/10. Well, why am I substituting that in? Because my x, which is my shoe length, is my x. 11 and 8/10 times 3 and 66 plus 25.3 gives me a height of 68.488, which I'm going to round to 68.49 inches. If you use the model, what would you predict his height to be? Well, let's try here. 130 minus 5 times 11 and 8/10. Y equals 130 minus 5 times 11 and 8/10 gives me 71 inches. Which model was closer? Well, the second one. Is that model a better fit for the data? Is that model a better fit for the data? Why or why not? So this is a tough question. Notice these are actually slope-intercept form. Even though the x is not closest, I want it to be close. So y equals 3 and 6600x plus 25 and 3/10. Y equals negative 5x plus 130. Why is this, even though it gave me 71, not the better choice? The key is the slope. We've already said that this is a positive linear relationship. If it's positive, my slope has to be positive. This has the line going downhill. We know that it's not a negative slope. This is a negative relationship. So is this the better choice? Absolutely not. Even though it's closer for that particular one, this line, this equation will be better for all. Okay? So it's important to know, hey, it's linear. Is it a positive or a negative relationship? Moving on. Okay, so we're still, residuals. I would make sure that you have this written down. I would make sure that you have this somewhere written down. We will be spending the next 2 or 3 lessons talking about residuals. Residuals can be both positive and negative. They're like our deviations, okay? The deviation's how far away from the center. Well, in this case, our center is the line of best fit. Our residual is telling me, is it above, positive, or is it below that line of best fit? In this case, okay, we predicted 71 and 42 hundredths of an inch. And you can read this and say, okay, his actual height was 74. So we take 74 minus 71 and 42 hundredths. We're off by 2 and 58 hundredths of an inch. We can find all of the residual values of everything if we know the actual and what we have based off of our heights. And we'll probably do a little example with this with our own shoes and our height. So here's what happened. I'm not going to do them all. I'm going to do a couple. Just by looking at this residual, we know this is positive because his real height was bigger than the line. This one's negative because this is 65. We don't know what the predicted is yet until we substitute it in, but I can guarantee this predicted is going to be bigger than 65. So what do? We get our calculator. We do 25 and 3/10 plus 3 and 66 hundredths times 11 and 8/10. And it gives me 68 and 488. I'm going to go 68 and 49. That's how I'm getting my negative 3 and 49 hundredths. Okay? So the key with residuals is the actual height or the actual value minus the predicted. Where do we get the predicted? We get the predicted by substituting in to the equation. We get the predicted by substituting into that equation. Because remember, maybe, we know that this line is the best line for all of these points. But notice how none of the points are actually on that. Some of them are above it, which means it has a positive residual value. Some are below, which means it has a negative residual value. Residual is the actual minus predicted. Okay, so we're not going to complete all that. If the residuals tend to be small, if the residuals are between 1 and 2, what does that tell me? Well, that tells me all of those points are close to my line. The closer the residuals are, the better my data is. It's just like that deviation. The closer that deviation was to the mean, that means the center of the data is all right there. If we've got residuals that are like 35 and negative 27, they're really far away. Those are outliers. We want all of our points to be somewhat close to that line. So the most common choice for best line is squared residuals. And it's going to go into all of this kind of stuff. But let's talk about how we're going to make a residual line from our calculator. So let's go back up all the way to our data here. This was the data given to me, the x values and the y values. I'm going to show you how they got their equation. So I'm going to try to do this without screwing things up. Here's my calculator. The first thing that I'm going to do is I need to enter that data. I enter that data by pressing the stat button. So step 1, press stat. I'm now at edit calc tests. To enter that, I press edit. Step 2, press edit. Notice how I already have these in there? Well, I want to show you how I'm going to do that. I highlight L1, I clear it. I press down, I highlight L2, I press clear. I go back to L1. To enter these in, I physically enter in my numbers. So I'm not going to show you this. I put 12.6, enter. 11 and 8/10, enter. 12 and 2/10, enter. I'm going to stop saying that now because I'm going to screw myself up as I'm doing it. But I'm entering in all of my x values first. There's my last x value, 11 and 8/10. Notice how it says L1 and in parentheses it says 10. That's the number of data points. I press enter and it says L1 11. There's nothing there. Now I go to L2 and I enter in all of my L2. 74, 65, 71, 67, 69, 68, 70, 69, 72, 71. Notice how all of my data matches up at the bottom, 11 and 8/10 and 71. If I had an extra number down here in my x and not my y, I did something wrong. Okay, I don't know how well you can see that, but there's my numbers. So now we need to find the line. To find the line, I press stat again. We want to go over to calculate. Okay, we do have linreg right here. This is a linear regression that says ax plus b. I want you to get into the habit of just scrolling down or pressing 4. It says X list, Y list, frequency list, store. I want you to keep pressing enter until it gives you numbers. We're only concerned right now about the A and B because Y equals AX plus B. Notice AX is 3 6/10 X plus B, which is 25.27, which they round to 3. Let's see how close we are. They told us the equation was 25.3 and 3.66. So let's take a look again. 3.657, oh, they round that to the 100th. 25.3, oh man, we have the same exact equation that they do. So one more time, how do I do this? To get my line of best fit, my linear regression, I press stat, edit's highlighted, I press edit. I enter in all of my numbers. To clear out one of those, I highlight L1 and then I press clear. I'm not going to do that. Once I've entered them all in, I press stat. I move my right arrow over to calculate. I want number 4, linear regression AX plus B. Y equals MX plus B? Absolutely. I press 4. I press enter until I come to this. Y equals AX plus B. We're going to deal with R in a little bit. That's the correlation coefficient, but we're not there yet. Okay? So I will help you if you need help with the calculators when you come in. This is linear regression, line of best fit, which we absolutely will be using.